Welcome back. Now, last class we considered bivariant analysis and we used Titanic dataset. I said you can get Titanic datasets on GitHub or Kaggle. That's the dataset we have been using, and we imported it. We imported different libraries at the beginning. That is the pandas, the NumPy, Seaborn, maplotplib, and we read through our dataset into DF. And then we removed every missing row using the drop NA. Then because of we performing statistics, numerical statistics, so I decided to replace the string data feed rather in sex. If you look at it, they are string items here. So I had to convert them to numeric so that it can aid in the analysis. All right, so we used this library sklearn pre-processing, and then we imported label encoder. All right, and thereafter we performed the replacement. Looking at it here, you can see 0011. Okay, so then we move on to ppmc product moment, fencing product moment correlation. Then we use the scipy stat for it, and then we also did for spearman rank and Kendertalby. Now we moving on to regression analysis. Okay, regression. Regression analysis. All right, so if you are just coming to join the class, you can go to your ANA PowerShell. That is Anaconda, Anaconda PowerShell. You click on it. Once it's open this way, you may have to change your the directory because it will open on the original directory source. So if the folder that your file, the dataset is stored is on a desktop, then it means you have to change. Mine is on a desktop, like Python. I created a folder named Python, and that is where I store my work into. So I have to then use cd, which means that change directory, desktop, space desktop, enter, then enter cd space, then Python, the name of my folder, then enter thereafter Jupyter notebook just to start my notebook. Once you start and it opens, it will come this way. All right, so now we want to look at this regression analysis using the same thing. So if you'll be starting for that, that is, I mean, you'll be starting with the regression analysis, then you may have to perform this first. You import these libraries and then you reach this dataset into your notebook. Okay, I'm using this df to hold this. All right, so then perform these, and then this you can stop here, and then thereafter we'll come to today's menu, which is regression analysis. All right, so we want to check. We have different type of regression analysis. Usually regression analysis is used to predict, to test for effect and impact. Okay, whereby your dependent variable is continuous, your independent variable is categorical. Okay, so we have linear regression, we have multiple linear regression, we have logistic binary regression, we have logistic multinomial regression. Okay, and when we have cost regression and the rest of them. All right, so we will be looking at linear regression. All right, so fasten your bets and let's dive into today's menu. All right, so let's start with linear regression. All right, so for the first one, we'll be using sklearn dot linear. Okay, sk sklearn sklearn dot linear. Okay, model. import linear regression. Okay, so that is what we will be doing now. We'll be using this sklearn, and then what we're doing is linear regression. So let's declaration 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 of independent variable, which is your predictor, and dependent variable, which is your outcome. Okay, so let's go. X is equals to df. So this is our predictor. Okay, then our y is our outcome. I guess it's okay now. Uh, so I'm going to then put a value here now. Let's assume predictor is sex. Doing linear regression is just one independent and one dependent. Okay, then our y is fair. All right, so we've declared the variable. Okay, so let's go to model fits. Model fits. Model is equals to linear regression. That is what we imported. Then let's do model fit. Dot fit x is capital letter X. Right. Let's print. Coefficient. Intercepts. Intercepts. That should run. Have error. Okay. I already has no attribute coef. Okay, so we have the issue coef. That's one again and see. Model dots. Okay, I just has no attribute coef. Let's look for it again. Okay, since it's an abbreviate of this, let's try this. Let's try this. Okay, this one again. Wow, we have results. Okay, we have results. So you can see the coefficient value is negatively skewed. We can see the intercepts. Okay. Now, for instance, our emphasis, let's assume we are looking towards our prediction. Then how do we go about predicting, okay, to see how it goes? So to do that, let's try this. Okay, let's change this now. Let's change this. Let's see, prediction using linear regression. Okay, right. So we still use the same code here. I will just copy. Okay, well, this time around, what we're going to have is different. It's different. Okay, so we're going to remove this. So we're going to name this prediction is equals to model dot predicts. What are we predicting? X. Okay, print prediction. Okay, that's one. You can see the fear that these people may likely pay. You can see likely pay, that is 009 009. Okay, this is the fear these people may likely pay using the gender. Okay, so to make it easier, let's do this. Let's put our X here. That's our outcome. Alright, so to put this in visuals, we can as well move this. Okay, let me copy this code. So we want to put it on visual. Before then, let's change this. Using scatter plots to show prediction. Okay, so let's just paste the other code we copied. I highlighted and I use Control C. So now next thing is using plots. Okay, so we use maplotplib initially, so I'm bringing it in here now. Matplotlib, we imported matplotlib. Let's just scan. Let's go there. See, matplot as matplotlib.pyplot as plt. So I'm making reference to it here now. X y color red label actual data. Okay, let's do this. Okay, plt dot plot. Okay, x prediction We have a color, due, we have a label, regression, regression, regression line. Okay, so we have this. If you want scatter plots, we have plots. So we are plotting on it the x, a prediction, the color, the label. Okay, let's add label title. So we are using a plt dot x label. Have this plt dot y label. We have here. Okay, then we have plt dot uh, title, right? Okay, so we have linear regression, actual versus predictors. Actual versus predictor. Should we use predictor or actual versus predictor? Okay. plt dot legend. Okay. Then we have a show method. Let's run this and see. The show is not defined. We still have our results. Okay. See. The reason why it says show is not defined was because we did not include a maplotplib. So let's just add it. So we have our results dot show. Okay. So this is the actual table here. Now this is the chart showing how gender or sex predicts uh, fear that this guy is paid. If you look at it, it's showing like a degendered line. It's horizontal. It's not ascending. It's as if it's just constant. It does not really actually predict it that much. You can see. So I guess with this, you can explain better. Looking at the prediction line, it's just horizontal. It wasn't moving across the price. So can we just change and see? Let's see if we can change. Let's change this to P class and see. P class. Let's see if P class, there is a class of the people actually predict it. Okay, let's see. Oh, you see, it's not ascending. The class is descending. Look at it. The other one, it looked as if it was constant. Now it's coming down. It's coming down. It's coming down. It's coming down. This is second class. This is the first class. First class, second class, and third class. Okay, you can see the prediction. So for first class, we have higher fear here, then followed by second class and the third class. So you can see that the class actually predicts. So you can take decision from it. Okay, those on first class, This is its second class, and this is third class. So you can see the fare, the money gained from these guys is higher than this, and the one gained from this is higher than this. All right, so that is how we've used it for predictions, and we've also seen the value here, but with the visuals is better off compared to the tables. All right, we are going to stop here. In our next class, we look at how to also present this in such a way that you can have your R square value, your R value, your T value, your 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 coefficients value. All right, for statistics purposes. All right, if you've not subscribed, please do well to subscribe. We'll meet the same time and same venue. Thank you for listening.